You are sitting in a quiet room. Maybe there is a faint hum, a fan turning, distant traffic, your own breath moving in and out. Sound feels normal, constant, almost invisible. You have never known a world without it. Sound is how you know things are there, even when you cannot see them. A door closing in another room, a voice calling your name, rain tapping on a window. It is vibration, air moving, tiny pushes against your ears. Simple. But now imagine this. Imagine removing the air. Every sound you know, gone. No footsteps, no voices, no wind, no music. Silence. This is what space is like. Almost perfect silence. Not because nothing happens, but because there is nothing there to carry sound. No air, no medium, no vibration reaching you. And yet, there was a time when the entire universe was not silent. There was a time when everything was sound. Not sound like music, not sound like voices, but something deeper, something older, something so powerful that it shaped everything that would ever exist. You know the name of it, the Big Bang. You have probably imagined it as an explosion, a bright flash, a sudden burst of light, but the truth is stranger. There was no space to explode into, no outside, no empty room waiting. Space itself was being created. Time itself was beginning. And in those first moments, the universe was not empty. It was dense, hot, filled with energy and particles packed so tightly that they behaved like a single seething fluid. And fluids can carry sound. In those early moments, the universe rang. Not metaphorically, physically. Pressure waves moved through the hot plasma of the young universe, and just like sound waves move through air. Except these waves were not gentle. They were enormous. They stretched across distances that would later become galaxies. They carried energy on a scale you cannot feel, cannot hear, cannot truly imagine. And yet, they left a trace, a fossil of sound, still here today, still measurable, still whispering. You are surrounded by it right now, not in the air, not in your ears, but in the structure of the universe itself. The pattern of galaxies, the distribution of matter, the faint glow of ancient radiation, all of it carries the imprint of those first sounds, a record, a memory of a time when the universe was young enough to vibrate, young enough to sing. But if space today is silent, and those waves can no longer travel the way they once did, then how do we know they existed? How did we ever hear something that happened nearly 14 billion years ago? Before stars, before planets, before even atoms as we know them? And if we could hear it again, what would the beginning of everything actually sound like? To understand the sound of the beginning, you have to start small again, back in your room, back with the air around you. When you speak, your vocal cords vibrate. They push against air molecules, creating waves. These waves travel outward, reaching someone else's ears. The speed of that sound is about 343 meters per second at room temperature. Fast, but limited, because sound depends on the medium. Denser materials carry sound faster. Steel, for example, can carry sound at over 5,000 meters per second. And that is why placing your ear against a rail can let you hear a distant train long before it arrives. Now imagine something much denser than steel. Imagine a universe filled with a hot plasma, a mixture of particles and light so tightly packed that it behaves like a thick fluid. This was the state of the universe about 380,000 years after the Big Bang. That might sound like a long time. It is not. Compared to the current age of the universe, about 13.8 billion years, it is a fraction so small, it is almost nothing. Less than 1% of 1%. a blink. At that time, the universe was about 3,000 degrees Celsius, too hot for atoms to hold together. Electrons and protons moved freely, constantly scattering light. The universe was opaque, like a dense fog. And inside that fog, pressure waves moved. And these were the first sounds, but they were not small. Each wave stretched across hundreds of thousands of light years. A light year is the distance light travels in 1 year, about 9.46 trillion kilometers. So these waves were unimaginably vast, and they were slow. Not slow in speed, but slow in frequency. The pitch of these sounds was incredibly low, so low that if you could somehow hear them, they would not sound like a tone. They would sound like a deep, rolling vibration, a hum, a pulse. One oscillation could take hundreds of thousands of years. Let that sink in. A single note lasting longer than all of human civilization combined. This is not sound as you know it. It is sound stretched across time itself. And yet, it followed the same physics: compression, rarefaction, pressure rising and falling. Now here is the first real anchor. These waves left a measurable imprint in something called the cosmic microwave background. This is the oldest light we can see. It comes from that moment when the universe cooled enough for atoms to form, allowing light to travel freely for the first time. That light is still reaching us today. It fills the entire sky, and it carries tiny temperature variations, differences of just 1 part in 100,000. Small, but not random. These patterns match the pressure waves from the early universe. The sound waves froze into place, like ripples in a pond suddenly turning to stone. This is how we know they were real. This is how we hear the Big Bang, not with ears, but with telescopes. Now zoom out. Those early sound waves did not just fade away. They shaped everything that came after. Where matter was slightly denser, gravity pulled more material together. Over millions and billions of years, those regions became galaxies, clusters, superclusters. The large-scale structure of the universe, the vast cosmic web, is a direct consequence of those early vibrations. In other words, the universe you see today is the echo of its own beginning. Every galaxy is part of that pattern, including ours, the Milky Way, which contains around 100 to 400 billion stars. Our sun is just one of them, a single point, and Earth is a small planet orbiting that star. Everything you know, every person, every story, every moment exists on that tiny world. Now pull back again. The Milky Way is about 100,000 light years across. That means light, the fastest thing in the universe, takes 100,000 years to travel from one side to the other. Sound, in any medium we know, would take far longer. But even this vast galaxy is just one of hundreds of billions in the observable universe. Some estimates suggest there may be over 2 trillion galaxies, each shaped in part by those early sound waves. Now here is the gut punch. Those original pressure waves had a characteristic scale, a preferred size. About 150 million parsecs today. A parsec is about 3.26 light years. So this scale is roughly 490 million light years. That is the wavelength of the ancient sound, 500 million light years. That is the size of a single ripple. And you are here, on a planet that is 12,742 kilometers wide, inside a galaxy that is 100,000 light years across, inside a universe structured by waves 500 million light years long. You are not even a fraction of a fraction of a fraction of that scale. You are smaller than the smallest detail of the pattern, and yet you can understand it. You can measure it. You can trace it back to a time before stars existed. Now imagine converting those ancient waves into something you can hear. Scientists have done this. They take the frequencies of those early oscillations and scale them up, compressing billions of years into seconds. The result is not a bang, not an explosion, but a deep, rising tone, a sound that starts low and slowly increases, like a distant engine turning on, or a breath being drawn in. It is haunting, because it is not chaotic. It is structured, ordered. The universe did not begin in noise. It began in patterns, in rhythms, in waves. But this raises a question. If the universe had a sound, then, and if that sound shaped everything we see today, what does that say about the nature of reality itself? Are we living inside the frozen echo of a moment that never truly ended? Now step back as far as you can, beyond galaxies, beyond clusters, beyond the cosmic web. Imagine the observable universe as a sphere, about 93 billion light-years across. That is the limit of what we can see, not the limit of what exists, just the limit of what light has had time to reach us. Inside this sphere are all the galaxies, all the stars, all the planets, all the history you know. And threaded through it all is a pattern, a memory, a fossil of sound. Those early pressure waves are no longer moving the way they once did. The universe has expanded, cooled, changed. The medium that carried them, hot plasma, no longer fills space. Atoms formed, stars ignited, galaxies evolved. The universe became transparent, quiet, silent. But the imprint remains, like footprints in sand that has turned to stone. You cannot hear the original sound anymore. Not directly. There is no air, no plasma dense enough, no medium to carry those vibrations to your ears. And even if there were, your ears would not be enough. The frequencies are too low, the scales too vast. It would not be a sound you recognize. It would be something deeper, something that does not fit into human senses. And yet, in another way, you are already hearing it, not with your ears, but with your understanding. Every time you look at an image of the cosmic microwave background, you are seeing the frozen ripples of those ancient waves. Every time scientists map the distribution of galaxies, they are tracing the echoes of that early rhythm. Every structure in the universe is, in some sense, a note in that original composition. And you are part of it. You are not separate from this story. The atoms in your body were formed in stars that formed because of those density fluctuations. Those fluctuations came from those pressure waves. Those waves came from the conditions of the early universe, which came from the beginning. So when you ask what the Big Bang sounded like, you are asking about something that is still shaping you, right now. Your existence is not just in the universe. It is of it, a continuation of processes that began nearly 14 billion years ago. And there is something strange about that, because sound, as you know it, is temporary, a vibration that rises and fades, a voice that speaks and falls silent. But this sound did not fade. It transformed. It stretched. It became structure. It became galaxies. It became stars. It became you. The universe does not remember in the way you do. It does not store memories as images or stories. It remembers through form, through pattern, through the arrangement of matter across unimaginable distances. And those patterns began as waves, as oscillations, as something very much like sound. So the next time you sit in a quiet room and you hear the faint hum of the world around you, think about this. Every sound you have ever heard is a small thing, a tiny ripple in air, gone in seconds. But there was a time when the entire universe was the ripple, when everything vibrated, when the scale of sound was so vast that it would take hundreds of thousands of years just to complete a single cycle. That moment is gone, but its echo is everywhere, in the galaxies, in the light, in you. And if the universe once rang with a sound so deep it shaped everything that would ever exist, then maybe silence is not the absence of sound. Maybe it is what remains after something too large to hear has already passed.